Hello, my name is Emma Frank. In this package, we are going to look at polynomials. Now, behavioral objectives. At the end of this teaching, the students should be able to define polynomial equation. The students should be able to apply the factor and remainder theorem to factorize any given polynomial. The students should be able to determine unknown constants of any given polynomial. These are the objectives. Now, let's look at definition of polynomial equation. A polynomial equation is any equation of the form f of x equal a subscript 0 x raised to n plus a subscript 1 x raised to n minus 1 plus a subscript 2 x raised to n minus 2 plus a subscript n x raised to n minus n. So any equation of this form is called polynomial, where a subscript o, a subscript 1, a subscript 0, s subscript 1, a subscript 2 till we have a subscript n are respectively the coefficients of each term in the polynomial equation. N is the degree of the polynomial. Thus, the degree of any polynomial is determined by the highest power by the highest power of the polynomial. So a polynomial equation is any equation of the form, f of x equal a subscript 0 x raised to n plus a subscript 1 x raised to n minus 1. We take like that, so we have a subscript n x raised to n minus n, where a subscript 0, a subscript 1, a subscript 2 till a subscript n are respectively the coefficients of each term in the polynomial equation, in this polynomial equation. So these ones are called coefficients. Coefficients is the number that you have before the variable. So all of these are the coefficients of the respective terms. Now we have n is the degree of the polynomial. So for whichever n, the polynomial will be called a polynomial of degree n. Now, When n equal 1, if n is 1, we'll have f of x equal a subscript 0, x plus a subscript 1. Here we'll have 1, then here we'll have 1 minus 1, which is 0. Anything raised to 0 is 1. So that's why we'll have it in this form. Okay. For n equal to, in this one, we'll now call it linear equation. Let me put that. This is called linear equation. When we have a polynomial where the highest power is 1. So we have linear equation. So for n is equal to, we have f of x equal a subscript 0x raised to 2 plus a subscript 1 x raised to 1 plus a subscript 2. Now this one is called quadratic equation. Alright, so for n equal 3, we have f of x will be equal a subscript 0 x raised to 3 plus a subscript 1 x raised to 2 plus a subscript 2 x plus a subscript 3. This one is called cubic. This one is called cubic equation. Now, for n is equal 4, we have quartic equation. For n is equal 5, we have quintic equation. So this is how it is named. And the next thing we'll look at is algebra of polynomials, where we'll talk about addition of polynomials, we will talk about subtraction, we will talk about multiplication, we also talk about division of polynomial. So we are going to look at addition, subtraction, and then multiplication, division. We will take example. Now let's look at this example. Given that f of x equal 3x cubed minus 2x squared plus 3x minus 4, and then p of x is another polynomial which is given by x cubed plus 4x squared minus 5x minus 6, q of x equal x squared minus 6x plus 2. We are going to find f of x plus p of x, p of x minus f of x, we find p of x times q of x. The solution for I, we need f of x plus p of x. Now we will arrange it using the normal addition of real numbers. F of x is 3x cubed minus 2x squared plus 3x minus 4. So we are going to add it to p of x, which is x cubed plus 4x squared minus 5x minus 6. Now look at that. The normal addition of real numbers. Now if you add this, we have minus 10. If you add this, we have minus 2x. Adding this, we have plus 2x squared. Minus 2 plus 4 is 2x is 2. So minus 2x squared plus 4x squared give us 2x squared. Now if we add this, we have 4x cubed. So this is how addition is done. Very simple. Let's also look at II, which talks about II. Says we should look for p of x minus f of x. Now p of x, we can do it in this way: x cubed plus 4x squared minus 5x minus 6. This is p of x minus f of x. F of x is 3x cubed minus 2x squared plus 3x minus 4. Okay, first let's open this bracket where we will have minus 3x cubed plus 2x squared. You know this, if you open here you have minus, open here you have plus. If you open here you have minus 3x, going here we have plus 4. Alright, we can now collect like terms where we have x cubed minus 3x cubed. You know this is x cubed, this is x cubed. So you go for x squared to have 4x squared plus 2x squared. Then we go for x terms to have minus 5x minus 3x. Then for these constants, we have minus 6 plus 4. And that will give us minus 2x cubed plus 6x squared, that is 4x squared plus 2x squared, minus 8x minus 2, that is minus 6 plus 4, minus 2. So this is p of x. This is p of x minus f of x. So is equal this, minus 2x cubed plus 4x squared minus 8x minus 2. That is how subtraction of polynomial is done. It's a very easy one. Now, in II, we talk about multiplying p of x by q of x. So we'll also look at that now. P of x times q of x could be done in two ways. Now look at this. P of x times q of x, using the first approach, we can multiply it the same way we multiply real numbers. X cubed plus 4x squared minus 5x minus 6, then x squared minus 6x plus 2. As we are multiplying. So now 2 times minus 6 give us minus 12. 2 times minus 5x give us minus 10x. 2 times 4x squared give us plus 8x squared. 2 times x cubed give us 2x cubed. Can also use this to multiply all the terms. Now minus 6x times minus 6 will give us plus 36x. Minus 6x times minus 5x will give us plus 30x squared. Minus 6x times 4x squared will give us minus 24x cubed. So minus 6x times x cubed will give us minus 6x raised to the power 4. Now we'll go with this. X squared times minus 6 give us minus 6x squared. X squared times minus 5x will give us minus 5x cubed. X squared times 4x squared will give us 4x raised to the power 4. X squared times x cubed will give us x raised to the power 5. Notice the arrangement that the powers are arranged in order so that the addition of the numbers will be easy. So here we have minus 12. We go here, we have plus 26x, that is 36 minus 10x. 36x minus 10x give us 26x. Okay, so 30x squared plus 8x squared will give us 38x squared minus 6x squared. We have plus 32x squared. Now we have minus 24 minus 5 give us minus 29x cubed plus 2x cubed. That gives us minus 27x cubed. Then we have this minus 6x raised to the power 4 plus 4x raised to the power 4. That will give us minus 2x raised to the power 4. Then we have x raised to the power 5. This becomes the result of p of x times q of x. That is method 1. Another method we can use, that is method 2. We can use each term to multiply the other polynomial, each term of a particular polynomial to multiply the other. For instance, p of x is equal to this, q of x is this. So we can write it in this form. X squared, you see, x, I'm taking x squared times x cubed plus 4x squared minus 5x minus 6. Then another term is minus 6x times x cubed plus 4x squared minus 5x minus 6. Another one is 2 times x cubed plus 4x squared minus 5x minus 6. So here we are going to use each term to multiply this one. Then this one also multiplies this. This also multiplies this. Let us start from here. Now that will give us, if you start the first one, we have x raised to the power 5. Then x times 4x squared, x squared times 4x squared give us 4x raised to the power 4. Then x squared times minus 5x give us minus 5x cubed. X squared times minus 6 give us minus 6x squared. We can also multiply the other, that is this. Minus 6x times x cubed will give us minus 6x raised to the power 4. Minus 6x times 4x squared give us minus 24x cubed. Minus 6x times minus 5x give us plus 30x raised to the power 2. Minus 6x times minus 6 will give us plus 36x. Then the last one, we use 2 to multiply x cubed. And we'll have 2x cubed. 2 times 4x squared give us plus 8x squared. 2 times minus 5x give us minus 10x. 2 times minus 6 give us minus 12. Alright. Notice also that the terms are arranged based on power. That is what I arranged so that when I'm adding it, it will be easy. Okay, so we have minus 12. If you add this, you have plus 26x. If you add this, this plus this is 38. 38 minus 6 gives us 32. So we have plus 32x squared. Then we'll add this again. Minus 5 minus 24 x cubed. Minus 5x cubed minus 24x cubed is giving us minus 29x cubed. Plus 2x cubed gives us minus 27x cubed. 4x raised to the power 4 minus 6x raised to the power 4 gives us minus 2x raised to the power 4. Then we add this to have 5x raised to the power 5. That is also p of x times q of x. We also notice the similarity of the results. Now this result and this one is the same. So based on any method you wish to use, that is how polynomials are multiplied. We'll now look at division of polynomials. The division of polynomials could be done using long division method. For example, find the quotients and remember when f of x equal to x cubed minus 3x squared plus x minus 9 is divided by x minus 2. Now we take the solution. You know, f of x is divided by x minus 2. So by long division method, we'll have 2x cubed minus 3x squared plus x minus 9 is dividing x minus 2. Now, 2x cubed divided by x give us 2x squared. How? Because 2x cubed means x into 3, 2x cubed, and we are dividing x, so this can cancel this. Look at this. So you remain 2x squared. Now 2x squared times x give us back 2x cubed. 2x squared times minus 2 give us minus 4x squared. Now we are going to subtract. If you subtract, you have minus 9. X minus 0 still give you x. Now minus 3 minus 3x squared minus 4x squared. So makes this plus. And what remains here is x squared. Now x squared divided by x will give us x. X times x, we get back to x squared. X times minus 2 give us minus 2x. By subtraction, we have minus 9. Then x minus make this plus. So we have 3x. 3x divided by x give us 3. 3 times x, we get back 3x. About 3x. 3x. Then 3 times 2 minus 6. So subtracting, we have minus 9 minus 6, and that gives us minus 3. That gives us minus 3 because minus is plus. Now this one is called quotients. Quotients. This one is the remainder. Is the remainder, and this is the divisor. The divisor. This one is the dividend. Dividend. This particular expression that we are dividing by x minus 2. This is the dividend, this is the quotient, this is the divisor, and this is the remainder. So the question is find the quotients and the remainder. Now this is the quotients, this is the remainder. So the remainder is minus 2. Now we are going to take another example. The remainder is minus 3. Sorry, it's minus 3. So we are going to take another example. Now, to this example, find the remainder when f of x equal 5x cubed plus 4x squared minus 2x plus 4 is divided by x plus 1. By our usual pattern, we are going to use long division method. And we'll put the dividend, which is 5x cubed plus 4x squared minus 2x plus 4. The divisor is x plus 1. Now, 5x cubed divided by x will give us 5x squared. 5x squared times x give us back 5x cubed. 5x squared times 1 plus 5x squared. Subtracting, we have 4 minus 2x. Now look at this. 4 minus 5x squared. 4x squared minus 5x squared is giving us minus x squared. Now, minus x squared divided by x will give us minus x. Because minus x times x will give us back minus x squared. Now, minus x times 1 will give us minus x. Subtracting, we have 4. Then, here we have minus 2x minus x. So that will give us minus x. Because adding here you have plus. So minus 2x plus x is minus x. So this divided by this, minus x divided by this will give us minus 1. Minus 1 times x will give us minus x. Minus 1 times 1 will give us minus 1. Subtracting, we have 4 minus 1 give us 5. Now, minus x minus x will make it plus. So what we have there is 0. Now, this is the remainder because we were asked to find the remainder when this is divided by this. So the remainder here is 5. This is the remainder. This is the remainder, which is 5. All right. And this will lead us to the remainders theorem. The remainders theorem states that if a polynomial f of x is dividing x minus a, the remainder r is equal to f of a. This is what the theorem states. The remainder theorem states that if f of x is dividing x minus a, the remainder r is equal to f of a. Now let's prove this theorem. We know that if f of x is dividing the divisor, we'll have something of this form: q of x times x minus a. That is, if f of x is dividing x minus a, we'll have q of x times this plus remainder r. Why do we say that? Because from here, we notice that f of x is this, which is the dividends. As you use the dividends to divide the divisor, what you have is the quotients, the divisor, plus the remainder. If we multiply this quotient by the divisor, added to the remainder, we will get back the whole of this polynomial, f of x. So that is what we are saying here, that f of x will be equal q of x, which is the quotient, x minus a, which is the divisor, and then plus r, which is the remainder. Now, making x subject of the formula from the divisor. You know, the divisor is x minus a. So we'll have x equal a. Now let's substitute. Substituting x equal a into f of x. Look at f of x. When we substitute x equal a, we will have f of a equal q of a times a minus a. You know, a is taking the place of x. You know, x is equal a. So, plus what's r? And what do we see? See that f of a will be equal q of a times 0. How? Plus a minus a is 0 plus r. So what it means is that by time 0 times q of a, what we have is that r equal f of a, or you say a of a equal r, which is what this theorem states. Okay, we want to apply it. Now, we'll take it from this question. Even with this, we can also apply it to see the relationship, what the remainder theorem talks about. Remainder theorem says that, like we were asked to find the remainder when f of x is equal to this is divided by x plus 1, that we may not go this long division method. We can use the remainder theorem to get it very easily. Now see what we'll do applying remainder theorem. We want to go back to this question because we are asked to find the remainder. So because the dividends is given, which is f of x equal 5x cubed plus 4x squared minus 2x plus 4, and the divisor is x plus 1, we are going to make x subject of the formula from the divisor. And when we do that, we now substitute it into f of x. That will give us the remainder. Now let's see it. F of x equal 5x cubed plus 4x squared minus 2x plus 4. We know that f of x is divided by x plus 1. Now, making x subject of the formula here, we will have that x is equal minus 1. Now, substitute x equal minus 1 into f of x. If you substitute this into f of x, we will have f of minus 1 will be equal 5 minus 1 cubed plus 4 minus 1 square minus 2 minus 1 plus 4. And that will give us 5 minus 1, because minus 1 raised to the power 3 is minus 1, plus 4 times 1, minus 1 square is 1, plus 2 plus 4. Now this will give us minus 5 plus 4. Minus 5 plus 4. Okay, minus 5 plus 4 plus 6. Now, minus 5 plus 4. Minus 5 plus 4 square. Minus 5 plus 4 is minus 1. So we have minus 5 plus 4 is equal minus 1 plus 6. So, minus 1 plus 6 become 5. which is the remainder. And that was exactly what we have from here. The remainder is 5. So instead of going long division method, you can use the remainder theorem by making x subject of the formula from the divisor and substitute in the given dividends. Once you put that, whatever result is the remainder. So the remainder theorem is very, very applicable when we are looking for remainder. It makes the work very easy. All right, we'll go to the next subtopic. We are looking at the zero of a polynomial. Let f of x be a polynomial function. The value of x at which f of x equals 0 is called the zero of the polynomial f of x. Let f of x be a polynomial function. The value of x at which f of x equals 0 is called the zero of the polynomial f of x. Now, let's take example so that we really understand what the zero of polynomial is all about. Now look at the example. Find the zero of the polynomial g of x equal 2x cubed minus 3x squared plus 4x plus 9. We'll take the solution. G of x equal 2x cubed minus 3x squared plus 4x plus 9. Now we are going to assume the values of x for which g of x will be equal 0. And I'll start this way. Assume x equal 1. I will have g of 1 equal 2 times 1 cubed minus 3x squared minus 3 times 1 squared plus 4 times 1 plus 9. And that will give us 2 minus 3 plus 4 plus 9, which is equal, this plus this. 4 plus 2 is 6. 6 plus 9, 15. 15 minus 3. So we have 15 minus 3, which is 12, not equal 0. So 12 that we have is not equal 0. Now we are also going to assume x equal minus 1. If I assume x equal minus 1, I will have g of minus 1 will be equal 2 minus 1 cubed minus 3 minus 1 square plus 4 minus 1 plus 9. That will give us 2 minus 1, because minus 1 cubed is minus 1. So minus 3 times 1. Minus 1 square give us 1 plus, 4 times minus 1 give us minus 4 plus 9. And that will give us minus 2 minus 3 minus 4 plus 9. Now all these minus, if you add them, you have minus 2 minus 3 minus 4 is minus 9 plus 9, which is 0. Therefore, x equal minus 1 is the zero of g of x. That is the zero of the polynomial g of x. So the zero of this particular polynomial is x equal minus 1. Minus 1 is the zero of the polynomials. Now, what do we use the zero of polynomials to do? This will lead us to factor theorem. the factor theorem. Let f of x be a polynomial function if x equal a is the zero is the zero of f of x, then x minus a is one of the factors of f of x. If x is equal a is the zero of the polynomial, then x minus a, that is taking this back, must be the factor of the particular polynomial. So let us look at example. Example, use factor theorem. Use the factor theorem to obtain the factors of the polynomial equation f of x equal x cubed plus 2x squared minus x minus 2. So let's look at the solution. We have that f of x equal x cubed plus 2x squared minus x minus 2. Now, we are going to find the zero of this polynomial, so that if we have the zero, then we will know that we have a factor also using the factor theorem. Now, assume x equal 1. You have f of 1 equal 1 cubed plus 2, 1 squared minus 1 minus 2. So f of 1 will be equal 1 plus 2 minus 1 minus 2. And this will give us 3 minus 3, which is equal 0. Now, since x is equal 1, since x equal 1 is the zero of the polynomial f of x, it means that x minus 1, you see, because if I take this back here, I will have minus 1. So x minus 1 is one of the factors of f of x. That's what it means. So by long division method, I can get other factors. Now let's look at that. If x minus 1 is one of the factors, then I can divide it to get other factors. The polynomial is x cubed plus 2x squared minus x minus 2. So x cubed divided by x will give me x squared. X squared times x give me back x cubed. X squared times minus 1 is x squared. Subtracting, I will have minus 2 minus x. And look at this. 2x squared minus x squared. That will give me 3x squared. Now 3x squared divided by x will give me plus 3x. Okay. 3x times x will give me 3x squared. 3x times minus 1 will give me minus 3x. Then we have minus 2. Now look at this. Minus x minus 3x will now give us 2x. That is plus 2x, because this is plus. 2x divided by x will give us plus 2. Right. 2 times minus 1. 2 times x will give us 2x. 2 times minus 1 will give us minus 2. If you subtract, everything becomes 0. which shows that truly this is a factor, one of the factors of this. So f of x then becomes, f of x now becomes x minus 1 as a factor. Then we have x squared plus 3x plus 2 as a factor. Now we can solve this, solving the quadratic factor. Solving this, we will have x squared plus 3x plus 2. We know that by factorization we have x squared plus 2x plus x plus 2. X squared plus 2x plus x plus 2. That is by grouping the terms 2. We know of quadratic equation. You can also watch it in this package so that you understand the factorization properly. Now, I can factor out what is common, which is x. So we'll have x plus 2. What is common here is 1. So I have x plus 2, which means x plus 1, x plus 2 are also factors. Therefore, f of x equals, the first factor was x minus 1. The second one is x plus 1. Then we have the third one, x plus 2. These are the factors of f of x. If these factors are multiplied, we can get back the polynomial function. Can get back this polynomial function. You can also try that to see. So we also take another example. The next example, we are looking at this. Form a polynomial in x whose zeros are minus 2, minus 1, and 3. So we pick the solution. We know that x equal minus 2 as is given is the 0. X equal minus 1. X equal 3. These are the zeros of the polynomial, because so you should form a polynomial in x whose zeros are these. Now, if these are the zeros of the polynomial, it means that x plus 2, x plus 1, x minus 3 are factors from factor theorem and 0 of a polynomial that we have done. We now understand that these are the factors. So that let the polynomial be f of x, which implies that f of x will be equal x plus 2 as factors, x plus 1, x minus 3. Now, these are factors such that when multiplied, we get the polynomial f of x. Now notice one thing, that a polynomial of degree n will have n factors. Like we have 3 factors here, we are expecting a polynomial of degree 3. If we have a polynomial of degree 4, we are going to get 4 factors. Okay, let's find the polynomial by multiplying this. I'll start by multiplying these two so that it will be easier. X plus 2, x times x will give us x squared. X times minus 3x is minus x, plus 1 times x is x, 1 times minus 3 is minus 3. Okay, so we then have x plus 2, x squared minus 2x minus 3. Yes, because minus 3x plus x is minus 2x. So these two, we can now multiply them to have f of x equals x times x squared give us x cubed, x times minus 2x give us minus 2x squared, x times minus 3 give us minus 3x. 2 times x squared give us plus 2x squared. 2 times minus x minus 2x give us minus 4x. So 2 times minus 3 is minus 6. And that will give us x cubed. Now look at this. Minus x squared plus minus 2x squared plus 2x squared is 0. Have minus 3x minus 4x is minus 7x minus 6. This is the polynomial that has these factors, So f of x equals x cubed minus 7x minus 6. Okay, so that is how it is done. Now, next we look at factorization of polynomial. We have seen that the zero of a polynomial and the factor theorem have a strong relation. Therefore, a polynomial of higher degree can be factorized using the idea of zero of polynomial and the factor theorem. So we take this example. Factorize 6x cubed plus 5x squared minus 8x minus 3. Solution. Or let f of x equal 6x cubed plus 5x squared minus 8x minus 3. So, if you have that, we now apply the idea of zero of a polynomial. We are applying this so that we can get one of the factors, and from there we can get other factors. Now, assume x equal 1, you have f of 1 equals 6 1 cubed plus 5 times 1 square minus 8 times 1 minus 3. Here we have 6 plus 5 minus 8 minus 3. And this gives us 11 minus 11, which is 0. Okay. Now, since x equal 1 is the 0 of f of x, it implies that x minus 1 is one of the factors of f of x. Now, to get the other factors, we are going to use long division method. We use long division method. We know that x minus 1 is one of the factors. So we are dividing 6x cubed plus 5x squared minus 8x minus 3. Now 6x cubed divided by x will give us 6x squared. 6x squared times x, we get back 6x cubed. Another one is 6x squared times minus 1 will give us minus 6x squared. So by subtracting, we have 3 minus 8x, then 5 minus 6x squared. 5x squared minus 6x squared give us 11x squared. 11x squared divided by x will give us plus 11x. 11x times x will give us 11x squared. 11x times minus 1 give us minus 11x. Subtracting, we have minus 3. Then minus 8x minus 11x will give us 3x. 3x divided by x give us plus 3. 3 times x, we get back 3x. 3 times minus 1 give us minus 3. Subtracting, we have 0. So that shows that x minus 1 is really the factor. Now we have f of x equals x minus 1. 6x squared plus 11x plus 3. We can then solve this quadratic part. Here we are looking for two numbers such that, okay, let's solve this. 6x squared plus 11x plus 3. We know that this is a quadratic equation when it is not in unity. Two numbers we add, we have 11 here, and if we multiply, we have the product of 6 and 3. That is, if we add the two numbers, we have 11. If we multiply, we have 18, because 6 times 3 is 18. And this number must be 9 and 2. So we have 6x squared plus 9x plus 2x plus 3. That will give us 6x squared plus 9x in brackets, 2x plus 3 also in brackets. Here we factor out 3x, and we will have 2x plus 3, because 3x times this can give us back here. Then this times this can give us this. So plus 1 is also the factor here. So you have 2 plus 3. The brackets are equal, which means 3x plus 1 and 2x plus 3 are the factors of this quadratic. Therefore, f of x now become x minus 1. We also have 3x plus 1 and 2x plus 3. So these are the factors of f of x. So you can see how the zero of polynomial and the factor theory can help us to factorize a particular polynomial. This is how it is done. The next subtopic is determination of constants of a polynomial. For example, the remainder when 2x cubed plus px squared plus qx plus 1 is divided by x minus 1 is 7. When it is divided by x minus 2, it is 39. Find the values of p and q. Now let's pick the solution. X minus 1 and x minus 2 are factors. And so if these are factors, from the Mendel's theorem, we know that x is equal 1 and x is equal 2 will give us a remainder of 7. So we can make x subject of the formula from here and here. All right, so from x minus 1, making x the subject of the formula, we have x equal 1. Now, substituting into the given equation, the given expression the given equation. Let's put it equation. The given equation, letting f of x equal to x cubed plus px squared plus qx plus 1. We have that f of 1, that f of 1 will be equal 2 times 1 cube plus p times 1 square plus q times 1 plus 1. And we are told that this will give us a remainder of 7. So we'll have 2 plus p plus q plus 1 equals 7, which means p plus q equals 7 minus 3. Now, 2 plus 1 is 3. So when you cross it here, you have minus 3. So p plus q equals 4. Call this equation 1. Now, also, from x minus 2, x will be equal to substituting in f of x, we have f of 2 will be equal to 2 cube plus p 2 square plus q times 2 plus 1, and that will give us 2 times 8 plus p times 4 plus 2q plus 1. This is 16 plus 4p plus 2q plus 1. Now, we are told that the remainder is 39. So, we have 4p plus 2q plus 17 equal 39. 4p plus 2q will be equal 39 minus 17. Now, 4p plus 2q, 39 minus 17 will give us 22. Yes, 39 minus 17, 22. Okay. So, I can divide so that the value will be easy, will be lesser. Dividing through by 2, we'll have 2p plus q equal 11. Call this equation 2. Now we are going to solve equation 1 and 2 simultaneously. And by elimination method, okay, we know that we can remove q. And solve for p. So, from 1 and 2, for equation 1 and 2, subtracting 1, equation 1, from equation 2, we'll have 2p plus q equal 11, p plus q equal 4. If you subtract it, we'll have p, 2p minus p is p. Then 11 minus 4 is 7. So we have p equals 7. Now, substituting p equals 7 into equation 1. Equation 1 is p plus q equal 4. Now p is 7, so we have 7 plus q equal 4, which means q equal 4 minus 7, so q equal minus 3. Therefore, f of x equal 2x cubed plus p x squared plus q x plus 1. The value of p and q is now determined. Will now be equal f of x equal 2x cubed plus 7, because p is 7, minus 3x plus 1. So that is how we can determine the constants. So we have this as a complete polynomial in x. That is how it is done. Let us take another example on determination of constants of a polynomial. If x minus 1, x plus 1, and x minus 2 are factors of the polynomial ax cubed plus bx squared plus cx minus 1, find a, b, and c respectively. Now, we are asked to find these constants a, b, and c. So, solution, know that f of x is, let f of x equal ax cubed plus bx squared plus cx minus 1. Now, since x minus 1 is a factor, it means that x equal 1 is what will give us the remainder. Now, if we substitute it here, we have f of 1 equal a times 1 cube plus b 1 square plus c times 1 minus 1. That will give us a plus b plus c minus 1, which also means we can write it in this way: a plus b plus c equal 1. So this is equation 1. Also, from this, making x subject of the formula, we will have x is equal minus 1. Now, substituting in f of x, we will have f of minus 1 equal a minus 1 cube plus b minus 1 square plus c times minus 1 minus 1. And that will give us minus a, look at this, minus a plus b minus c minus 1. Now, rearranging, we can have minus a plus b minus c equal 1. This is equation 2. I'm transferring this to this side of f of x, so we have 1. This is equation 2. Now, we can also make x subject of the formula from this factor, and by substituting in f of x, we have f of 2, because there x will be equal to. So if we put it here, we have f of 2 equal a 2 cube plus b 2 square plus c times 2 minus 1. And that will give us 8a plus 4b plus 2c minus 1, which we can write, taking here to this way, we can have 8a plus 4b plus 2c equal 1. So this is equation 3. 3 equations. And we can solve these 3 equations simultaneously. We want to start from 1. We'll pick 1 and 2. So from equations 1 and 2, from equations 1 and 2. Equation 1 is a plus b plus c equal 1. Then 2 is minus a plus b minus c equal 1. So adding, if you add these two now, you have 2b equal 2. So b equal 2 divided by 2, that is dividing both sides by 2, and then which is 1. Now from equation 1 and 3, from equation 1 and 3, 1 is a plus b plus c equal 1. 3 is 8a plus 4b plus 2c equal 1. So I want to also eliminate it. And to do that, let's start with eliminating c. The coefficients must be equal. So we are going to multiply equation 1 by 2. Multiplying equation 1 by 2, we have 2a plus 2b plus 2c equal 2. Then equation 3 is 8a plus 4b plus 2c equal 1. Now, I'm going to subtract equation. This is equation 4. This is equation 4. And this is equation 3. Now, subtracting 4, equation 4, from equation 3, because equation 3 is higher than this, so let's do it that way to get the positive value. We have 6a plus 2b equal minus 1. 8a minus 2a give us 6a. 4b minus 2b give us 2b. 2c minus 2c is 0. So 1 minus 2 is minus 1. Now, substituting b equal 1. You know, we had here that b is 1 from here. B is equal 1. So if we substitute it here, we have 6a plus 2 times 1 equal minus 1, which means 6a plus 2 equal minus 1. 6a equal minus 1 minus 2. That is this going this way. So 6a equal minus 3. A equal minus 3 over 6, which is minus 1 over 2. That is the value of a minus 1 over 2. Now, we are going to substitute a equal minus 1 over 2, b equal 1 into equation 1. And we have equation 1 that a plus b plus c equal 1. A plus b plus c equal 1, which means minus 1 over 2 plus 1 plus c equal 1. And if we add this by taking LCM, that is minus 1 over 2 plus 1, we have minus 1 plus 2, which is 1 over 2. So the whole of this is 1 over 2 plus c equal 1. Right. Then c will be equal 1 minus 1 over 2. So that c is taking LCM of this also, we have, now notice, 1 minus 1 over 2. So 2 divided by this, we have 2 minus 1, which is 1 over 2. So c is 1 over 2. Okay, so it means that f of x equals f of x from the given question, which is equal a x cubed plus b x squared plus cx minus 1 now become f of x equal a. A is minus 1 over 2, that is minus x cubed over 2 plus x squared, because b is 1, plus x over 2 minus 1. So this becomes the polynomial. We have determined the constants. So this is how it is done. So with this, we have come to the end of this package on the polynomials. So I want you to take your studies very serious. Read your book. Anywhere you don't understand, you can pick your DVD and select the topic. It's very easy. Mathematics is fun now. It's fun. It's not stressful. So with this, you'll be able to solve any mathematics problems that you have been having. My name is Ima Frank. I remain your tutor. As you continue to learn, that is how you get more knowledge. Remember, knowledge is power.